Okay, so in this video what we're going to do is we're going to perform a hypothesis test at two different significance levels, and then we're going to compare the results. So in this hypothesis test we're told that the mean length of the great white shark is 21 feet, and to test and see if the sharks off the coast of Bermuda are longer than that, a sample of 35 sharks is selected, and it has a mean of 22.75 feet with a standard deviation of 5.07 feet. And so what I'm going to have you do in a minute is I'm going to have you perform this test at the 0.05 significance level, and then again at the 0.01 significance level. And then go ahead and compare the results and see if they're different, and if they are, see if you can figure out why they're different. So you can go ahead and you can pause the video, and then when you're done you can turn the video back on, and we're going to look at the results of these two tests. Okay, so let's go ahead and see how you did here. For this first test here, we're going to perform at the 0.05 significance level. The hypothesis here is the hypothesized mean will be 21 feet, and we're wanting to see if the sharks off the coast of Bermuda are longer than that. So the null hypothesis here is going to say the sharks off the coast of Bermuda are no longer than 21 feet. They're the same. There's no difference. But the alternative, the competing claim that I would like to show is no, actually the sharks off the coast of Bermuda are longer than 21 feet. So that's my hypothesis. Okay, so now I need to determine the rejection region here. And this is a right-tailed test, so I'm going to shade this right tail here, and our alpha is 0.01. And so if we go to our table, this is a one-tailed test, so I go to one-tailed our alpha in this case is 0.05, and then our next test will be 0.01. So alpha, one-tailed alpha, 0.05. Go down to the bottom, I have a critical z value of 1.645. So this is 1.645. Okay, so this side will be reject H naught, and over here is fail to reject H naught. Okay, so now I calculate the test statistic. So my sample mean is 22.75, the hypothesized mean is 21, standard deviation is 5.07 over the square root of 35. Okay, so putting this in my calculator, 22.75 minus 21 divided by 5.07 over the square root of 35, all of that in parentheses, and I get 2.04. Okay, so now let's look and see my rejection. My critical value is 1.645, so if it's greater than that, my test statistic is greater than that, then I reject H naught. And in this case, it is greater than that, right? It's up here somewhere. 2.04 would lie in the rejection region. Okay, and maybe I can zoom in a little bit on that. So that lies in the rejection region. So I'm going to reject H naught. And this means that there is enough evidence to conclude true mean length is longer than 21 feet. And so this means there's enough evidence to conclude that the true mean length of the sharks off the coast of Bermuda are longer than 21 feet. Okay? And so now let's see if it changes if I test this at the 0.01 significance level. Okay? When you test it at the 0.01 significance level, your hypothesis and your test statistic doesn't change. Okay? So we're still going to be, we're still going to assume that the true mean is equal to 21 feet. Okay, and I want to check to see if it's greater than 21 feet. So this doesn't change here. Okay, so now the main thing that changes is this critical, or this rejection region. Okay, so the critical Z value is going to change on this, isn't it? Okay, so in particular, my alpha is 0.01. That's a smaller alpha, which means the test here is more significant. The smaller the alpha, the more significant the test. And so I'm going to do alpha, one-tailed alpha, 0.01. Down at the bottom, I get a critical Z value of 2.326. So this is 2.326. Right? And so now, in order to reject, it has to be above 2.326. That's my reject H naught. Over here, we would fail to reject H naught. So if you look, what changes is that this rejection region gets pushed further out, right? Instead of 1.645, it's 2.326, and so your test statistic would have to be bigger in order to reject H naught. So in this case, the test statistic is the same. It's still 2.04, and that does not lie in the rejection region. 2.04, okay, lies in the fail to reject region. So I'm going to fail to reject H naught. Oh, you know what? I misnumbered these steps. That should be step 2. That should be 3. This should be 4. So I failed to reject H naught, and so step 5 would be there is not enough evidence to conclude true mean length is longer than 21 feet. So when we performed it at the 0.01 significance level, there was not enough evidence to conclude that the true mean length of the sharks was longer than 21 feet. So either the sharks are long off the coast of Bermuda are longer, or they're not. Okay, and what changes here, the results of this test are different, and what changes here is at the 0.01 significance level, I'm requiring more evidence before I reject H naught. Okay, so that's what makes this test more significant. So here it only has to go past 1.645, which it does, and then I have enough evidence to reject, and so I do. And so at this significance level, I do have enough evidence to reject. So I'm weighing evidence, and I'm just requiring more evidence in this case. So this pushes it back to 2.326, and now this thing has to go all the way beyond that, and it doesn't go beyond that. There's not enough evidence. It does not lie in the rejection region. So in this case, there's not enough evidence to conclude the true mean length of sharks is longer than 21 feet. So if you remember I said that alpha was the probability of committing a type 1 error. So the type 1 error is actually rejecting H0 when H0 is true. So this doesn't require as much evidence to reject H0. And so I have a higher chance. There's a 5% chance of rejecting H0 when H0 is true. Here there's only a 1% chance. So I've increased the amount of evidence, making it harder to reject H0, and therefore the probability of rejecting H0 is going to be lower. Okay? So the type 1 error is rejecting H0 when it's true. The alpha is the probability of doing that. In this case, when I reject H0, I have a 5% chance of rejecting it. So it doesn't mean, whenever you reject H0, that doesn't mean you're committing an error. In fact, I have a 95% chance of making the right decision, right? And so there's a good chance I'm making the right decision here. But if I really want to make sure I don't make that error, then I can increase my alpha and make it harder to reject. Okay? But in this case, I would run the risk of committing a type 2 error, which is accepting H0 when H0 is false. Okay? And you should reject it. So I run the risk of committing that in this case. And so it's important when you perform a hypothesis test to know what these two errors are, and to know, kind of as you're doing the test, which one of the errors you run the risk of committing, and then you can interpret the results based on that. So the point here is when you do the test, you don't know 100% if you're making the right decision. Okay? And so you need to be aware of that and know that you're weighing evidence. Know that in this case you're requiring more evidence to reject. And so if you can reject it at this significance level, that's more significant than being able to reject it at this significance level. So those are some of the ideas of the type 1, type 2 error. In the next video, I'll actually write out definitions of those errors, and we'll talk a little bit about them, and then we'll look through some of our previous hypothesis tests to see if we can determine what the errors are, what the two errors are, and which error we would run the risk of committing. So, okay, so with that, we'll go on to the next video.